discuss about a data type. Today we're going to discuss about data types, Java data types. So what are the different data types? So data types is going to tell you what type of data and how much size, how much memory it occupies. That is what this data types will tell you. What type of data you want to store, how much it occupies, how much memory it occupies. That's the data types means. So data types specifies the size and type of values that can be stored in a memory or in an identifier. Okay. So identifier is nothing but where any kind of variable where you will store the data, right? Yesterday we used assignment operator to store right side value you are copying to left side variable. So that is done by assignment operator. The copying is done by assignment operator. That's a responsibility of assignment operator. That's why I'm explaining each part. You need to grab them. That's a very crucial. If you are we're going word by word, and if you don't understand any word, let me know. I'll explain once again. So basics are very crucial. If you have a strong foundation, and then the programming language is very easy. Initially, you have to do a lot of hard work. Anything, if you are learning basics, that will give you a strong foundation for anything. It doesn't matter, okay? So we have two types of data types, primitive and non-primitive data types. So primitive data types, again, declared as 8 types. 8 data types we have. Primitive data types again. So 8 data types: boolean, char, byte, short, int, long, float, double. So these are the 8 primitive data types. So data types means not only this, you have one more type, that is non-primitive data types. Non-primitive data types. So we have string class. String is a class. Class also one data type. Any class, not only string class, any class is so that's why I mentioned here, any class, any interface name, any enum, array, string, these are all comes under non-primitive data types. So then what is the difference between primitive and non-primitive? Primitive data types, you can store only single value. But in the non-primitive data types, you can store multiple values. So how? See, class contains many members, right? Class inside, what are the members?
We have finals and variables, methods, constructors, or blocks.
Right? You have variables, methods, constructors, blocks. These are the members of a class. So like even string means a group of characters is called a string. Array means a group of elements is stored in the array. That is many you can store in the non-primitive data types. But in the primitive, you can store only a single value. So that's the difference between primitive and non-primitive. So what are the primitive data types? So you have integer family, there are 4. Byte, short, int, long. These are the 4 data types for integer numbers if you want to store. If you want to store floating point values, you have 2 types, float to double. If you want to store character, you have a char data type. If you want to store a boolean value, you have boolean data type. So these are the primitive and non-primitive data types. So primitive data types are 8. And non-primitive data types, as I mentioned, see, you have a string, array. These are list to, set to, these are interfaces, stack, vector, these are classes. and dictionary. So this is another one. And all the user-defined classes. All user-defined classes will be treated as a non-primitive data type. As I mentioned, class, any interface is going to come under non-primitive data type. So primitive also called intrinsic or built-in types, and non-primitive data types also called derived. We are deriving a reference data type. So any reference or you are deriving, that's a non-primitive data types. So Boolean, first one, Boolean data type. The Boolean data type has only two possible values. So one is true and false only you can store in the Boolean data type. So if your value is true, what is the data type you need to take? A Boolean data type. If your value is a false, then what is the data type in the left side you have to declare? Boolean. So use this data type for simple flags that track true or false conditions. So this data type represents the 1 bit of information, but its size isn't something not precisely defined. Okay, so there is no size for this Boolean, but you can store only a true or false. See that? Data type, variable name, assignment operator, true. That means I'm assigning a true value to B. That means B contains what value?
True.
True. And Boolean B1 equal to false. So that means B1 contains false value. So next Boolean Bn, I didn't assign any value. Then what value will be there here? The default value is false. The default value for Boolean is false. So the default value for Boolean is false. So, and integer, int x equal to 20, int y equal to 10. That means x contains 20, y contains 10. That means 10 is stored in y, 20 is stored in x. So assignment operator. Assignment operator means I already told, one more time I'm repeating. The right side value will be copied into left side variable. Who will do that? Assignment operator will do that. So double equal to is used always to compare numbers. If you want to compare numbers, so what is the operator you need to use? Double equal. If you use a single equal to, it won't compare. Okay, so you have to be very careful here using these operators. These are called operators. Assignment operator, comparison operator. And there is a conditional operators also. We have a greater than, less than, greater than or equal to, less than or equal to, equal to. These are the conditional operators. If you use conditional operators between numbers, the result will be a Boolean value. That means either true or false only you will get. If you use this greater than, less than, greater than or equal to, less than or equal to between numbers, what is the output you will get? Either true or false only you will get, not number. You won't get a number. You will get Boolean value. So in the expressions you will write like this. See, x greater than y. So what is the x value? 20. Greater than y value 10. 20 greater than 10. So what is the output you will get?
True.
True. It's a true condition. So these are the expressions. X less than y. So true means you have to store in the Boolean, right? So that's why B2 is a Boolean variable type. X less than Y, 20 less than 10. True or false?
False.
False. So false, this right side is giving a value. False. So this expression output, what is that? False. False you can store in the B3. So B3 type is a Boolean data type. Because based on this output, you need to declare this data type here. So Boolean B4 equal to X double equal to Y. X double equal to Y. 20 double equal to 10. So true or false?
False.
False. So B4 contains a false. So this is the directly you are not storing a true or false, but with expressions also you will get the value. So that is how you can use all the conditional operators we are using. So if I use mathematical operators, what are mathematical operators? Plus, minus, multiplication, division. These are the mathematical operators. When you use mathematical operators between numbers, you will get number only. You won't get a Boolean value. Okay?
Mm-hmm.
So these are the few points we need to remember. And there is a logical operators. Logical operators are and double ampersand or type symbol, not equal to, not equal to. So these logical operators, so just to compare, okay, so between, see now, when you use logical operators, first understand this, what will happen. Logical AND operator, if you use between the two variables, so what is the output you will get? That I have given in this table. You need to go through these tables. See, variable 1 value is true. And this is the AND, right? AND operator. Variable 2 value is true. True and true, then you will get a true. That means if you use AND operator between two variables, both the values are true, the result will be true. In the AND case, if any one is false, the result will be always false. Remember this. So when you will get a true in the AND case, AND means both should be true. So if any one is false, what is the result you will get? False only. False and true, false. False and false, false. So not equal operator. Not equal means it is saying, okay, true not equal to false. True, right?
Mm-hmm.
So that is result you will get a true. True not equal to true. False. Basically those are equal, but we are saying not equal. False not equal to true. True. False not equal to false. False. False equal to false, but we are saying not equal. False. So these are the tables very important for your understanding. First, logical OR operators. So variable 1 is true, or variable 2 is R means any one. R means any one. R means any one. And means both. So true or true, true. True or false, true. False or true, true. False or false equal to false. So did you understand the and between and or?
Yeah, I've done logical gates before, so this is familiar to me.
Yeah, so that's a very important. These are you're going to use in the programming these basics widely. Okay, that's why now see, let's apply these concepts here. B and B1. So what is a B value? Let's see here. What is a B value? True. And B1 value false. B and B1 and operator. So what is the output you will get here?
False.
False. True and false, false only. So B or B1, true or false. So what is the output you will get?
True.
True. Excellent. B not equal to B1. True not equal to false.
True.
True. Right. So this is the kind of, how you will use, and based on this output, the data type also you declared a boolean, because this is returning a boolean. That's a boolean value. Boolean data type. Boolean data type. Lowercase you have to write. Okay. Remember this. Lowercase boolean. That's a primitive data types. First one is done. Any questions on the boolean data type before going for the second one?
So far, so good.
Okay, perfect. So next, char data type. Second one, char data type. So if you want to store a single character in the memory, you will use a char data type. Single character. Character means what are all things you will consider as a character?
Alphabet, alphanumerical, single, like digits, any sort of single, item is considered as a character.
See, alphabets, numbers, special characters, spaces. Special characters means even comma, dot, anything. And special character means at the rate, hash, dollar, percentage, anything, right? The even plus, minus. These are all single characters only. You should not write more than one character. Then that is not going to be a char. Char means single character. If you club two characters and putting in the char data type, it won't accept. It will throw compile time error. So that's what I say. See here, it is used to store single character. This is the one, single character in a memory. That should be enclosed within single quotes. How you wrap the character value? In single quotes. So how much memory it occupies? The char data type is a 16-bit of memory it occupies. So char C, capital D in single quotes. Char C1, small a in single quotes. Char C2 equal to dollar in single quotes. Char C3, so space, I put in the single quotes. Char C5, 5, I kept in single quotes. Char C4, A3 in single quotes. Is this correct?
No.
Why? We kept it 2 characters. That's wrong. Because 2 characters are included here. This is a wrong. But these are all valid. Okay? I'm showing a valid ones and invalid ones. Okay? So that you will get, so what type of data you can store in the char. Okay? So default value is Unicode. This is called Unicode. So this is the default value of character. And char occupies 16-bit of memory. That means 2 bytes. 1 byte equal to 8 bits. So it occupies, when you declare here char CD, so 2 bytes of memory over. If you declare another char C1 equal to A, another 2 bytes are over. So that means it is occupying. So whenever you create a char data type variable, it occupies 2 bytes. So 1 byte equal to 8 bits and 2 bytes equal to 16-bit of memory. So that's the char data type. Next, integer family. So even char also integer family only. So every character has internally one integer number. Internally, I have an integer number, every character. So integer families, you want to store integer type of data. you will use 4 data types. One is byte, short, int, long. So these are the 4 you can use to store integer type of data. So byte, first one. So byte data is an 8-bit signed memory it occupies. The minimum value is -128 and maximum value is 127. So that's the minimum and maximum values. So then you can declare byte B4 equal to 5. So that means it occupies 8-bit of memory. That means 1 byte, right? 1 byte it occupies. So this is the lowest one which saves the memory also. So whenever you want to save the memory, you can declare that a byte data type. Short. The short data type occupies 16-bit of memory. The minimum to value is -32,768 and a maximum value is 32,767. 32,767. So that's the short s equal to. So you can declare whatever the value you want. So basically, you can declare this short to save memory in large arrays. So where memory saving actually matters, you can go for this or this one. And int. So by default, when you declare int data type, it stores 32-bit of memory. 32-bit of memory it occupies. And the minimum value of int is -2 power 31 and maximum value is 2 power 31 minus 1. So that's the minimum and max values. And int I equal to 10, when you declare this 32-bit of memory is over. So you need to remember this memory sizes. Byte 8-bit of memory occupies. Short 16-bit of memory it occupies. Integer 32-bit of memory it occupies. And long, bigger integer numbers if you want to store, then you can use a long. So it is 64-bit of memory it occupies. So the minimum value is -2 power 63 and maximum value is 2 power 63 minus 1. So that's the total integer family. And you can see long L equal to, say, bigger integer numbers, capital L. So this occupies 64-bit of memory. See how you can declare, so values and how you can know. This is the compact code and this is the equivalent to, but longer code. So how it is a longer, let me explain. See here, you created a variable and assigning the value directly. And here, you created a variable first, then in the next line, you are assigning the value. So this single line is equal to these 2 lines. So that means it occupies more lines of code, right? This is not optimized code. You want to give a value, directly give value, assign the value in the same line. So that the number of lines of code will be reduced. So that is this one. Int b equal to 6. Int b, and see we declared first. Declared. This is called declaration. And this is called assigning a value. So this one, declaring a variable and assigning a value in the same line. So please understand the wordings how I am using. First, we declared a variable here. In the next line, assigning the value to that variable. But here, declared a variable and assigned a value directly. But here, I didn't assign a value, I declared. So same here, int c equal to 7. Here int c first declared, Then in the next line, I assigned 7 to C. Int D equal to, I'm using this C plus 1. And here I declared a D. And in the next line, C plus 1, I am assigning to D. Now, what is the D value?
C plus 1.
Hmm?
C plus 1.
Give the value, final value.
Oh, sorry. 8.
8. C value 7, right? 7 plus 1.
Mm-hmm.
It will come, right? The C value will come here. What is the value? 7. 7 plus 1, 8. So that's always, you will store and you will reuse. The variable name only you will call wherever you need that value. Direct value you won't write, okay, in the calculations. String S equal to, I am amico. And first you declare the string. Then we are assigning the value. So this is the short and longer code, how to declare variables. Next, decimal values. So what are the decimal values? You have 2 decimal values, right? One is a float, double. So float data type occupies 32-bit of memory, same as integer. Both the integer memory size, float memory size is same. But what is the difference between both of them? The data type. That is a integer and this one is a floating value. So its range, it changes. So with this one is when you can use a float, when you have a decimals like this. 3.6 cap left. Cap left tells you it's a floating value. Cap left tells you it's a floating value. So double. So double data type, so will tell you double D equal to bigger decimal values. If you want to store, you can use a double. So it occupies 64-bit of memory. Same as a long. Long is integer values, but double is a floating values, decimals. Decimals. These are the decimals, right? After dot, whatever is, that's a decimals. After dot, whatever is a decimals. But this dot before, that is an integer number. This is an integer number. Integer dot, a decimal value. That's a decimal values. If you want to store, you can use float or double data types. Okay, is this clear?
Mm-hmm.
Okay, so there is one more concept, typecasting. So what is meant by typecasting? When you will use that, and before that, first you need to understand that type mismatch error. So type mismatch error you will get in your programs when your left-hand side and right-hand side data type is not same. Okay? Left-hand side one data type, right-hand side a different value or data type. Then you will get a type mismatch error. And the left-hand side variable memory size is smaller than right-hand side variable memory size. Then also you will get a type mismatch error. That's why I am asking, remember this memory sizes.
Mm-hmm.
Okay? So these are the 2 cases you will get a type mismatch error. Then how can you handle this type mismatch error? By using typecasting. So you'll use a typecasting. So what is mean by typecasting? So it is a process of converting the value of one data type, class or interface into another data type, class or interface is called typecasting. So please remember this is in the interviews they're asking, what is mean by typecasting? What is a typecasting? It is a process of converting the value of one data type or class or interface into another data type, class or interface is called typecasting. See that. So data type, variable name equal to the parenthesis. The parenthesis inside you have to write left side data type. Why you need to write left side data type? This value data type is a different. That is the reason you are getting a type mismatch. To solve that type mismatch error, you make this value also equal to left side data type. And you are converting. You're converting this value to left side format. That is called typecasting. Are you clear? I'm converting the right side value to left format. So that's why left side data type, if you write, it will convert into that format. So now once you do a typecasting, left and right hand side, both same data type will be there. Then your issue will be solved. Same you can apply for interfaces also. So for example, interface 2 variable, you're assigning to interface 1 variable, then you will get a type mismatch. Then how to solve that? Apply the typecasting. So put a round brackets before this right side variable and write the left side interface name, then it will be solved. This one we are using in our automation. That's why I'm giving here in heads up in the Java itself. Because this is a Java concept only you're using in the automation. Okay. And examples. So for this examples, let's go to see one by one example. So int I equal to 50. What is the integer memory size?
2 bytes, right?
No. 32-bit. 32-bit means 4 bytes. 4 bytes. 4 bytes, right? 4 bytes means 4 8 32. 32-bit of memory. So short, how many bit of memory? How much? What is the short memory size? 16.
Or you mentioned is 16, right? Yeah.
16.
So that is 2.
So now what you are doing? You are assigning I. I means what is the I data type?
Int.
So integer you are placing inside the short. Is it possible?
No.
Why it's not possible?
16-bit doesn't go into 8-bit.
No. See, what is the assignment operator, sir? I told you again. Right side value. Again, you are forgetting that concept. Right side value will be copied into
left side, yeah.
Left side. So now right side, what is the right side memory size? 32-bit.
32-bit
will be copied into 16-bit. Is it
No.
going to happen?
Not happening.
So because 32-bit you cannot fit in the 16-bit, right? That's why memory sizes are different here. Same integer family only. Short also integer family, integer also integer family only. But what is the difference here? The memory sizes are not matching. The left side less memory, right side bigger memory. That's why you will get a type mismatch error here. Then how can you solve this? How to solve that? Right side variable before, put a parenthesis inside. What you need to do? You convert the integer to short. So when you convert the integer to short, and then it will become a 16-bit. And the S1 also short. This is also short. That's why you will solve that type mismatch error. But same data type you can convert, but not different data types. Okay, please remember. Same family you can do that. Numbers you can do, but string and numbers you cannot do. Okay. That is not possible. That's not typecasting won't be done for strings and numbers between. Not happens. See, this is also number, right? But floating. Float f equal to 3.5. But I assigned this float value to integer. Integer and float both are same memory size. So that memory wise, there is no issue. Then what is the main problem here? What is the main problem here?
There's a type mismatch.
Okay, type mismatch, because why you are getting type mismatch? What is the reason?
Just float has decimal values and integer doesn't.
Integer values. The data types are different.
Data
types are different. That's why you're getting a type mismatch. Then how can you solve? You convert the float into integer. So that's what I'm doing, converting float into integer. So that's why you will get a I3 value only 3. not 0.5. Okay, so that's how we can solve the type mismatch error. So are you clear on these two examples? So go through this one more time and come back. So tomorrow we'll see the rest of the things. Okay. So any doubts in this?
No, none so far.